is David Kaaret. I'm here today as part of a series of talks on MarkLogic financial services use cases. Each of these talks focuses on a specific use case where MarkLogic offers clear benefits and has real-world experience. Today, we're going to talk about trade hubs and how they can be used to create a golden source of truth. There's quite a bit to trade hubs. We'll start with what a trade hub is and why do you need one, followed by a discussion on why they are hard to build and use. Then we'll move on to the technology you need to create a world-class trade hub in an efficient way. Finally, we'll look at a real-world implementation. So before we get to why you need one, what is a trade hub? Don't financial services firms already have lots of databases of trade data? What's different about a trade hub from the databases of trade data firms have always had in the past is that in the past, each desk maintained its own data and handled its own reporting. Today, risk management and reporting occurs at a firm-wide basis instead of at the desk level, as was the case when many legacy infrastructures were built. Without a trade hub, it is hard to handle these needs. What does a trade hub need to do? Not every implementation needs to do everything, but common functionality includes capturing trades, enhancing data, verifying messages, and converting different message types to a common format. Perhaps most importantly, trade hubs need to provide easy and efficient access to a lot of complex data. What kind of data goes into a trade hub? Basically what you would expect. Quotes, orders, data about clients and the instruments traded, and a lot of related material. The basic reason it is hard to build and access a trade hub is because data, and especially trade data, is complicated. With a traditional relational-based approach, every column of every row of every table may need to be modeled and ETL developed for it before development can start. This can literally add years to development. With newer schemaless approaches, development can begin immediately after data load, but the modeling and transformation of the data is done at the application level and must be repeated for each new application. Neither of these approaches provides a viable, extendable approach to building a platform for long-term use. Another way to look at this is the path from quote request to regulatory reporting is long and complicated. Each instrument type has its own set of systems, and each trade must pass through multiple systems to handle quote responses, trade validation and capture, reconciliation, and more. Each system has its own data store with its own data structures. When trading systems were created, there was little effort to agree on a common standard because doing so would have slowed the creation of the systems and would have provided minimal benefit. In the past, this was okay because reporting and risk analysis was done at the desk or product level. Today, firms need to do their analysis at the firm level. This means they need to aggregate all their holdings. The lack of commonality makes life hard and creates the need to build trades. As an example of the complexity of trade data, this slide shows some of the message types a complex trading system will have to handle. Some, like Swift and FPML, are highly complex with the standard encompassing many separate message types. Other kinds of trades may have ad hoc schemes which can change from message to message. So let's move on to how you implement a trade hub. What are some of the core capabilities you need to implement a first-class trade hub? Basically, you need technologies which let you build the hub in an iterative, agile way. You also need powerful search and query capabilities. For real-time systems, you may need ACID transactions to be sure your results are accurate. MarkLogic trade hubs are generally built on the MarkLogic data platform. The Data Hub platform is available on-prem and as a managed service. The Data Hub platform automates the creation of building trade hubs. It allows users to load relational, unstructured, and semi-structured XML and JSON data to create a single unified hub. The Data Hub provides graphical tools to define data models, transformations of incoming data, deduplication of data, and other capabilities. As we've discussed, the primary issue in building a trade hub is the data modeling and ETL needed to turn a large number of diverse data sources into a single unified data set. MarkLogic solves this problem with the idea of agile data modeling. Agile data modeling allows data models to be built based on immediate needs and then enhanced and improved over time with the changes to the model applying to existing data as well as new data. When changes are made to the data model, MarkLogic automatically applies them to both new incoming data and also to existing data. This is possible because the original data is still accessible. MarkLogic keeps the original as-is data and also builds a curated version based on the data model. Very few data platforms are capable of changing data models on the fly like this, and it's the core of MarkLogic's agile data model and harmonization approach. With agile data modeling, developers can do just-in-time modeling and harmonization and do the minimum needed for the next deliverable while gradually building an ever more robust platform. ACID means data is never lost, even if the server holding the data crashes. It also means that queries give consistent answers. Many data platforms use an eventually consistent approach, which means that data can be lost if a server crashes. It can also mean that queries may miss some of the data in the system and give inconsistent results. For real-time systems, this can lead to risk analysis or regulatory reports which are inaccurate. So let's move from building a trade hub to using one. The obvious drawback of flexible data modeling is that users will sometimes need to access data which has not been formally modeled. MarkLogic greatly alleviates this by providing extensive capabilities for data against structured, semi-structured, and unstructured data. These capabilities fall into three broad classes: MarkLogic's universal index, its world-class search engine, and its tight integration of semantics and document technology. With MarkLogic's universal index, as soon as data is loaded, it immediately becomes available for structured queries. Descriptors in the data, XML attributes and CVS field descriptors can be queried against by any user who understands what's in the data. This means power users can perform structured queries even when no data modeling or ETL has occurred. MarkLogic includes a world-class search engine. Many of the most important information providers in areas like legal, financial services, physics, engineering, and media have built their sites on top of MarkLogic because of the power it provides. Faceting, stemming are all there to help users explore very large data sets and find the information they need. Even without any data modeling or data harmonization, the data access needs of many use cases can largely be handled by the functionality provided by MarkLogic's universal index and search alone. Ontologies allow firms to embed their knowledge about their firms and industries. With ontology, MarkLogic becomes a smart database and can use this knowledge to guide and enhance users' searches and queries. So let's look at an example of how this works. A user does a query on bond and high yield. They get some results. Looking at the results, they realize that items that should be there are missing. With a trade hub which includes an ontology on financial products, more accurate results can be obtained. By traversing the ontology, MarkLogic can determine that fixed income is an equivalent term to bond, and munis are a kind of bond. With this, an equivalent analysis on high yield searches and queries can be automatically expanded to incorporate the knowledge they provide. Ontologies can be industry-wide, like the one we just looked at, or they can be specific to a firm. With ontologies, firms can turn their data platform into a smart one and dramatically expand their ability to provide users with accurate and correct information. So a number of firms have built trade stores on MarkLogic. This slide describes one major financial services firm's experiences. The initial implementation was for MiFID II. The project first started with Oracle. However, the issues with handling complex trade data with relational technology made the project difficult and time-consuming, and they made the choice to switch to MarkLogic. The firm had two key goals. First, build a platform which could handle many regulations and not just be a point solution for a specific version of a specific one. Second, improve their time to market, both in terms of implementing regulations, but also in handling changing conditions like onboarding new data sets. There were a variety of other needs. For example, to handle regulatory logic at a hub level and not within the primary systems to make it easier to handle changing needs. There was also a critical need to handle semi-structured data coming in as XML and JSON, as a lot of trade data exists in these forms. With the MarkLogic-based platform, the firm met all these needs and was quickly able to build the trade store, which allowed them to generate regulatory reports, provide data to third parties quickly and efficiently, and use ontologies to make the data easier and more accessible. In this session, we've explored how MarkLogic can simplify the creation of trade stores and help firms provide abilities that otherwise are difficult to do. By combining agile data modeling with sophisticated multi-model data access approaches, trade store creation, trade hubs become a far easier task.